Alright, hello. I want to show you something I have been working on. It is based on the Joule thief and I call it a RE-EMF Charger. You know what back EMF is if you have seen my previous video. Well, let's get to it. I will show it, explain it to you, and I hope you have something you can do with it. Alright. Well, this is the new schematic that I have drawn for you, and it's called the RE-EMF Charger. What it can do, you can charge batteries, non-rechargeable batteries, old lead acid batteries. It will give it back a kick, just like the Bedini system does, but it's very efficient, and it works really fast. Alright, so I will point it out with my pen. I'm filming this with a camera, a photo camera, so if it sucks, too bad. You have to do it with this. Alright, this is my source. It's a 20 volt DC current. What happens is the plus goes through the diode to the battery that is to be charged. In this case I say it's a 12 volt battery, and I will explain you how to calculate. Well, a 12 volt battery, so the plus goes to the plus of the 12 volt battery. The minus goes on towards the coupling of the Joule thief style bifilar coil. It goes down one end into a resistor of 330 ohms to a resistor variable of 1 kilo ohm into the base of a transistor NPN NE3055. Alright, the other side goes through the coil into the collector of the NE3055 and back to the minus. Now, well, what happens here? You see I have made a connection and connected a diode back towards the plus of the battery. What happens in the system? This 12 volt divides itself over this battery, so it delivers 12 volt to the battery, 20 minus 12, 8 volts remain. 8 volts are placed over the circuit, the Joule thief circuit this actually is. And what happens, the 12 volt gets pulsed, and the amps going in the first direction through the battery is stored into the core of the Joule thief. And once the NPN transistor collapses again, then the back EMF from this coil gets released over the same charging battery. So what happens in this system is that you charge this battery with 12 volts, and after the transistor closes, it discharges the power that remains here with a higher voltage over the battery again. So what happens is that you get a charge 12 volts and about 200 volts, but with a spike, just like Bedini does. What happens is that this is way more efficient than anything I ever built. Before, to charge batteries, you use your power twice. Once in the conventional sense, 12 volts, say 50 milliamps or 1 amp, it doesn't matter, you can calculate how much amps you want to draw. Say 1 amp, the 1 amp and 8 volts is stored here, and once this transistor closes, it releases all that power, the 12 volts of the 8 volts with 1 amps, so that's 8 watts with a higher pulse, about 200 volts, over this battery again. So in one turn you have 2 charging pulses. How do I get this 20 volt DC power supply? I simply took an AC power supply about 12 volts. I made a bridge rectifier, and I use a capacitor to equal the voltage out, and this equals this schematic. So, and why is this diode here? Well, the whole Joule thief system works with very high back EMF pulses, and what I have noticed is that if you don't place this diode here, then your power supply might fry because you have such high spikes and a lot of power is transferred within this whole system. So placing this diode, just like here, you can place it here. If you place this diode over this power supply, you don't blow your power supply. And what you can do, you can charge your lead acid batteries really fast, and even old ones that are almost dead, if you let it charge overnight, over a couple of nights, this one gets back to its previous state. It gets stronger and stronger and stronger. And what you can also do is charge non-rechargeable batteries in this place, and that also works. The fun part is this doesn't heat up. And why doesn't it heat up? Because you use pulse power. You are pulsing this at a very high frequency, about 10 to 20 kilohertz, and this doesn't heat up. So you got a pulse of 10 kilohertz through this normally 12 volts at 1 amp, and if this collapses, then this one kicks in and it gives back like 200 volts in a Bedini style pulse back spike. This works like a charm. Build it, enjoy it, and let me know what you think about it. Alright, for now, Rene, that's me, Rene is out. Bye bye.